All right. Well, first of all, thank you for joining us, everyone. We appreciate your time. This is one of the most joyous days for us in MLPerf land as we get to share the results and all the hard work that everyone in the organization, all of our members have done. So, as a reminder, one, we're recording this call. And it will be probably shared back. Kelly, are we going to get the recording out in time, or is this just going to go up on the YouTube channel?
We shared in the Google Drive with everybody right after the meeting. We do remove the Q&A from it, but we share the overall video, and it'll be posted in the Drive shortly.
Perfect. And then there will be a slightly refined version posted on YouTube. Everything here is under embargo until 8/28 at 8 a.m. Pacific time. And once this briefing is done, it's open season on briefings for press and reporters. So many of our members will be doing briefings where you'll get to hear from the participants more directly. So the materials that should have been distributed to you last night, I believe, sort of late, we've got the MLPerf Inference results themselves, which I think we sent out in a sheet form, and we will be getting you Tableau either this morning or very shortly. We have the supplemental disclosure, which contains the written description by submitters of what's interesting about their results. And then we've got the press release. And the key thing here is the link here holds all of the documents. So if you forget anything, just go to this Google Drive, and anything that we want you to have will be in there. And hopefully nothing more. So I think most folks here have been to the briefing. Our goal is to provide, a neutral playing field where we can help educate everyone. We want folks to understand the results as much as they can. We know it's not necessarily the easiest thing in the world, but we want to help drive education of the broader public, of our friends in the press and analyst community, and really give our members an opportunity to shine. Ground rules here, as always, no competitive comparisons explicitly or implicitly. Our member companies are free to do that in their own blogs, in their own briefings, but at MLCommons, we don't want to really allow that. So please don't ask questions that might lead you in that direction or lead the speakers. Then they'll have to dance around it, or I'll kind of jump in. But please feel free to ask questions to help your understanding or the understanding of your readers and audience. So this is the agenda that we've got. It's a pretty standard one. We're going to talk about the new benchmark, some light analysis of the results, and then we're going to have open season on Q&A. A lot of this is pretty standard. MLCommons is a global engineering organization focused on building things for ML, spanning 6 out of 7 continents, as I like to say. Still looking for those members in Antarctica. We've got, well over 100 members and affiliates in academia, industry, small companies, again, spread all over, and tens of thousands of results. And that number, of course, climbs with every submission round and increasing breadth, right? And, if I was to sort of talk about our goal here as an organization, it's really, how can we help measure and therefore improve accuracy, safety, speed, and efficiency of AI, right? And, MLPerf really focuses in on, touches on 3 of those areas. In particular, the speed and efficiency, and to some extent, the accuracy as well. Why benchmarks? As all of us who have OKRs or other sort of goals, whether they're life goals or professional goals, when you set a goal, you can measure against it. And the thing I want to emphasize is that this is not just about creating a competition between vendors, but it's actually about creating a competition with ourselves, with the whole industry. How do we deliver the astounding capabilities of AI that, you know, I live in San Francisco, Waymos are on the street everywhere. That's powered by AI. How can we bring those capabilities to the broader world? And by having the industry go together, we go much farther, right? And so the point of the benchmarks is to point us all in the right direction, everyone in the industry, bring us into alignment, and then help improve things over time. You know, as a reminder, ML in particular is a full system problem that spans the gamut from the lowest level at what is the silicon process technology, what is the packaging, what is the memory, how do we assemble all of these things together at the lowest atomic level, all the way up to the macro scale level of how does the data center potentially operate, right? And everything in between. So when we look at how the industry tackles ML problems, we're looking at clever tricks that you play with data, sorting the data in clever ways, novel computer architectures, novel software and algorithms, and then increasingly how you assemble things at scale. And once upon a time, I used to say that scale wasn't actually much of a factor in inference, but one of the things that we'll see a little bit later is that scale is becoming an issue in inference as we start looking at some workloads that might span multiple systems. And just a reminder of the goals for MLPerf. You know, we want our benchmarks to be reproducible. That's critically important, not just for us and our members, but actually for everyone in the industry, right? So we have tools that let folks rerun submissions very easily. And that's very helpful for buyers, for customers who they maybe want to get a system, they get the system in place. How can they make sure it's relatively delivering its performance? How can they make sure that what's going on is accurate? And so that reproducibility is tremendously valuable, not just to us, but to the whole industry, right? Using representative workloads, right? We're actually capturing what's going on, what's relevant, what's important, and providing a fair and level playing field so everyone has an opportunity to demonstrate what's great about their architecture. Could we, John, could you mute yourself? We're picking up some audio from you. Thank you very much. And, you know, so those are just a handful of the goals here. I also want to emphasize the increase in breadth at MLPerf over time, right? You know, as I like to say, our tiny systems are just, you know, tens of microwatts up to, you know, 20 or so megawatt systems, right? And at the same time, we've been improving that breadth. We've also gone much deeper. There's this push on reproducibility, standardized methodology for training. One of the things I'm super proud of is we now have the ability to do power measurement for cloud data centers, for large-scale systems, something that will be rolling out more broadly throughout the benchmark suite. So there's a lot of improvements we make in addition to trying to keep abreast of the constantly changing workloads that I'll get to talk about in a bit. And we do have, the other thing I want to emphasize, sometimes overlooked, is there is an MLPerf compatibility table that indicates which benchmarks across which versions of MLPerf you can safely compare if you want to do historical trend analysis. So as you look at the results, just something I want to emphasize is that it is a lot of work to do any single result. You know, the way MLPerf works is there's a reference model, but the reference model is really designed to be readable. It's not designed for performance. And so what that means is everyone who submits has to go through and optimize their submission. That means tuning the model, tuning the infrastructure, you know, BIOS settings. There's just so many things that go into a submission. It's really significant work. And so, you know, in a lot of ways, it's like finishing a triathlon or an Ironman. Everyone who gets to the finish line actually has something to be very, very, very proud of. So what that means actually for folks in the press is that each submission, because it represents so much work, actually is saying something interesting. And I think the trick is, how can you look at them and discern what it is? Sometimes it's very obvious. This is, the first rollout of our new solution, but sometimes it can be more subtle. And so, these are some tips that I have from when I look at results. Again, try to look at some submissions where there's similarities and then also differences. And those differences can be things like, hey, we have a different software framework, a different inference engine. We've got maybe the same components, but in a different topology or configuration, maybe different scale. So as you look at those things, all of those can yield up potentially very interesting insights. Another one, this round has a lot of very interesting preview submissions. So looking at the progress from preview to available can be quite interesting. Right, and then the other thing to keep in mind, specifically with respect to power, is that the larger a system is, the better you're able to amortize the overhead. Now, Ray, you had an inline question. The blue is just sort of for things that are not necessarily, so the green I would look at as things that were running submissions on this roadmap, Ray. The blue is sort of a little bit more future looking, where things are still under development. Anyways, the larger a system is, just as you think about it, a system with one processor still has many of the same pieces of overhead, fans and whatnot, as a system with 2 or 8. And so as you think about power and other performance results, it's important to keep those things in mind. As a concrete example, a system with 1 processor and 1 accelerator is a bit different than 1 processor and 8 accelerators because of the proportional amount of processor available. Same thing holds for fans, for power distribution units, and so forth. So just a sort of second order effect to keep in mind. All right, diving into the actual inference benchmark. What's new this time around? So I think the biggest and most obvious thing is we've got a new benchmark, the mixture of experts benchmark task. This is a large language model test that spans actually 3 different subtasks, and that's new. We don't have anything quite like this before. And so it is a combination of code generation, Q&A, and solving math problems. So these are 3 things that many LLMs are used for, but it is all combined together here, and we'll talk about that in a little bit more detail later. This is an emerging architectural trend that's very exciting. Something we've seen deployed at scale by a number of industry leaders. And so it's very important for us to get that in, especially, I don't need to tell anyone that generative AI, large language model seems to be at the tips of everyone's tongue, fingers, keyboard, etc. Sometimes I want to emphasize that there are other things and other important workloads, but it is certainly one of the most interesting things today. Secondly, we adjusted the metrics that we report for all of our language modeling, our large language model tasks, to be consistent. Previously, Llama 270 billion, the new Mixtral 8x7 billion, or mixture of experts, measured using tokens per second, while GPT-J was using samples and queries. And so we decided to switch everything into tokens per second to be consistent. And for these, we have a conversion factor of 69. I think those are the really big changes this round. And as per usual, we will have a deep dive on the benchmark a little bit later. Just a reminder, we have, even though we might have a single workload, there's a lot of different ways it can be deployed, and these are often actually substantially different, and the tuning is different, right? We have single stream where you're getting 1 query at a time as if you have a single user. This is more common for Edge. And that has a different performance metric, the 90th percentile latency. You have multi-stream, which is, again, primarily an Edge sort of scenario. You can think of this as modeling things where you have multiple potentially synchronized streams of input that have to be handled with a certain latency constraint. Then we've got server and offline, which are required in our data center division, right? And server simulates random query arrival, and so there's a latency constraint in there, and you don't get to see every query at once, and so that forces a lot of optimization in the stack to tolerate that, right? Batch size suddenly becomes a lot more complicated, as an example. And then there's offline, where all the queries are available and there's no constraint. And so just, again, to refresh your memory, data center requires running server and offline. Edge is a single stream and offline with optional multi-stream for some benchmarks as it makes sense. And so just the thing to remember is, even if it's the same workload, the deployment scenario is totally different and may be stressing different aspects of the system. So here's an overview of the workload. We've highlighted at the bottom our new mixture of experts, along with the quality metrics that it has. And the data sets. And as I said, Miro, one of our co-chairs for MLPerf Inference, will talk about this in a little bit. And the latency constraints we picked for Mixtral are identical, actually, to our LLM Q&A. Time to first token of 2 seconds, and then throughput per additional token of 200 milliseconds. And so that's the constraint you must hit to have a valid server submission. But of course, many will be significantly faster. All right, so just kind of going through, what are the results we got? We got nearly 1,000 performance results, 31 power results, including actually every single benchmark and scenario, I believe, in data center. We got 34 results for our new mixture of experts benchmark, which is great. It's always exciting to see adoption of new benchmarks, but of course that changes over time. One of the things I mentioned is that each submission is a lot of effort. It's doubly a lot of effort for a new benchmark, right? That's the first time many people are seeing the code, working with it. And, so I'm always thrilled to see who's participating in the newest benchmark. We've got 22 submitting organizations. I want to specifically call out AMD, Sustainable Metal Cloud, SMC, and Untether AI. These are all first-time submitters. So kudos to them and all of their teams for getting engaged here. And in particular, one of the things that's really interesting about Untether is they did not just performance, but also power measurement as well, right? And there's very few folks who have been able to do both power and performance their first time out of the gate. So special tip of the hat there. And we also have power results from our friends at NVIDIA. And then the 8 organizations that submitted to the new mixture of experts benchmarks are up here as well. I'm not going to read everyone off. We've got a lot of folks on the slide, but, particular hats off to everyone who participated, and especially the folks who are stepping up for the first time. All right. So a few points that I want to just make. While we don't call out competitive comparisons, it's also, I think, part of our job in educating to just at least point out a few things that are novel in a very, non-discriminatory, even-handed way. So we've got one of the things that I'm very excited about. We have a ton of new processors, many of them in preview, actually. So, we've got the MI300X, AMD's Turin, next generation CPU is being used, the Google Trillium processor, Granite Rapids, Blackwell, and then Untethered Speed AI 240. So, these are all first-time appearances in MLPerf. And even more exciting for us is, for many of them, these might actually be the first public benchmark results for these processors, which is really cool. And it's an honor for us and for our members. So, as you're looking through these, you might take a look. And there's also a great deal of very interesting systems at very different scales. Like we're starting to see some distributed submissions, all sorts of different configurations coming through. All right, so Max Cherney asked the difference between preview and available. I think we should have a slide on that in here. Ooh, maybe we don't. All right, well, we should get a slide in there for this deck as if it gets distributed. Let me sort of talk through that. So in MLPerf, we have 3 different categories. RDI, which is research development and internal, that might reflect something that is not going to be yet generally available for quite a while. We have preview and available, all representing, different points on the spectrum of availability. If something is available, it generally means that you can buy all of the components, and all of the significant components are available. Right now, that doesn't mean you can necessarily go out and buy that exact system, right? But it means all the components individually are, right? So for instance, someone might be assembling a system in a very interesting way that's not quite what's commercially available, but each component is commercially available for sale, has a listed price, and the software is out there and can be reasonably used, right? So that's what available means. Preview means it will be available by the next submission round, right? But one or more components may not really be available. So sometimes that means we've got engineering samples that are being used, and those engineering samples might be shared with customers, but you can't really buy them. Or it might be something not quite a final revision of software or silicon or something of that nature. Or it may just not be available for sale quite yet. The rules of preview are you can do a preview submission, but then because it's a little bit harder to reproduce, you have to do an available submission subsequently to validate that performance. So you actually can trust the preview numbers because they will be backed up with a future available submission, but you will not be able to, the things that are listed here in preview, in many cases, you may not be able to go out and buy every single part in that system and build it yourself. That's a very good question. Did I get that clarified for you? Hopefully I did. If not, we can ask the question later. So a couple of points here I want to make. We just have a tremendous breadth and diversity of submissions. That's really exciting for us. Just, the more different systems that we see out there, the better for the industry, more opportunities and more things to compare and learn from. In particular, there's a lot of preview submissions this round that really represent many of the options that we as an industry will have over the next 6 to 12 months for our AI compute, right? And so it's really thrilling to be able to showcase that for everyone here. What does the landscape look like for the future of AI computing? We saw one of the first submissions using the FP4 numerical format. Many of the gains in performance on AI have come from reducing the precision all the way from, there was a time when people were thinking FP64, 64-bit floating point, might be very useful to maintain full accuracy, right? And one of the things we found is we can often use smaller formats, which reduce the memory footprint and allow us to do more efficient compute. And so seeing just the emergence of a new numerical format is really exciting for what it says for the whole industry. Many of the folks who are submitting on multi-generational hardware are seeing very significant performance gains, 2 to 4x, which is fantastic. A lot of the benchmarks that were introduced previously, we're seeing significant performance gains on just, 6 months later, up to 50%. So that's a really rapid pace of innovation that we're seeing, and that bodes well for the industry. So those are a few of the insights we can share. Of course, there's a lot more to be gleaned from looking at the results, and I'm sure many of our members will have other insights that they wish to share with you privately. So now I'm going to turn it over to Miro to go through the mixture of experts benchmark. Probably ran
Okay.
a little long, but
That's
here.
okay. All right. I hope everyone can hear me. So what I'll walk you through these new benchmarks that we have developed. And there is a reasoning within our working group was that as we see this trend that's been going on for several years, I think everybody's familiar with, that the models have been sort of increasing in size. That's causing significant issues in practical deployment, right? The cost to deploy this model is becoming higher. Making sure that you get throughput and latency appropriate for serving is becoming harder to reach. And we also see sort of this trend. Also, you can actually see in our benchmarks, right? In 3.1, we introduced Llama 270 billion. That was a year ago. Now there's a new family of models. At that time, that was the highest. Now the new one goes in hundreds, right? So to capture that, there's definitely, even just over a year, that would sort of that is a significant step in. And right now, it really doesn't show much of a sign of slowing down. Nevertheless, for practical purposes, it's not, it's becoming really tricky in deployment. So one of the sort of interesting ways has come out from a family of models called mixture of experts. Really, what that is at high level is that instead of having one large monolithic model, you actually would have several smaller models, which are termed the experts here, and you actually can generate results based on that, right? So anytime a query comes, it can be routed through one of the experts. So for any query, you actually only need to run a subset of the total model, just one of the experts, right? This of course allows improving the cost of deployment. It allows you to get better throughput, better latency, but very importantly, it allows for task specialization and adaptability, right? It's not necessarily that just like the model can have different architectures, for example, but these experts would be trained on different data, so that really would be experts in different sort of domains. And then as the tasks come, you can choose the best ones. It's not, yes?
I was just going to interject. One of the other things is it is also this benchmark is language modeling only. But if you want to do multimodal models where you're doing speech data, vision, text, blending these things together, it's an incredibly common technique used there. So that's also something to keep in mind in terms of the relevance and significance of the overall industry. Sorry for the interruption.
No, absolutely. And so the other thing also that happens was that not only this architecture has also proved to be very useful. When we look at actual results, when people testing them, the result that these MOEs that in actually is pretty small, they actually demonstrate that there are results comparable to some of the cutting edge large monolithic model, which is really exciting. So based on this, the work group has spawned a task force of experts to sort of study MOE field and develop a benchmark reference implementation and spec for this benchmark, which I will talk about next. Before getting to that, here is sort of high-level overview of what's happening in this type of AI models. On sort of left-hand side, we kind of see sort of a scheme that's blown up on the right-hand side, but really what's interesting is this layer that is covered in, that is sort of shown in blue, right? So here this switching FFN layers is effectively comprised of multiple FFNs. Each one is technically the expert here, right? And there's a router in front of it which basically routes it through one of these paths, and that is how the results are being generated here. You can go to the next slide. Now, to talk about specifics that the task force has developed, they've considered multiple options because there are multiple models that could have been chosen. At the end, we settled on a Mixtral 8x7B. Now, there was different families of model, really makes Roll appear to be preferable because of its open source nature. Also, there have been several choices for size. This is sort of a middle size that was chosen. And again, that was because it can address different types of hardware. So this, we want it to be accessible throughout the range of hardware. Now, very interesting thing has happened as sort of the task force was going through this, because of the nature of this of these models, that it has a multiple. That it sort of has multiple experts, right? It turns out that that having a single task probably would not necessarily exercise this type of model the best. Like our previous in Llama, we have Q&A. In GPTJ, we have summarization, but it was felt that to sort of showcase what MOEs can do, we should probably have multiple tasks. And so it was the task force settled on 3 different things, which sort of David mentioned before. But in more details, the Q&A is based on OpenORCA dataset, and that is really the same one as we used in Llama to 70 billion benchmark. The 2 new ones, or 2 different ones which we have never used, is GSMK dataset. That is a math reasoning dataset based on grade school math. And that's for sort of solving math. And the third is based on MPXP, which is really a coding data set. Now I'll show you some examples later. How they sort of get together to sort of to combine to have a total data set from each of these, we take 5,000 samples. So total data set that actually gets that needs to get processed is 3 times that, so it's 15,000 samples we draw from each one equally. As for any benchmark, part of the sort of specification needs to be latency and accuracy. So because we have 3 different benchmarks, there are 3 different accuracy criteria. For Q&A, we reuse what we have for Llama. For GSMK and for MBXP, this we basically run tests to sort of figure out where we are and what the sort of reference implementation gives us, and these are the values that task force set on. In terms of latency, this is what is important for server. This also comes in play in server, where sort of we simulate serving. Right, so time to first token is set up to 2 seconds, where you see the first token, and time per output token was 200 milliseconds. Again, this match Llama to 70 billion. Right, we have 3 tasks, we have 3 different tasks, but it's all about generating tokens. Right, and I would like to mention that so overall, this is definitely our most ambitious and most complex benchmark we have done. We are working on a blog that should hopefully be published at the same time as the result.
Yeah. So, Miro, there's a couple of questions from the audience I want to jump in and handle. So Dylan Patel asked, what prevents someone from quantizing and fine-tuning on the test set? We have dedicated calibration data sets that are of limited size. So it's just enough to allow for quantization and centering the distributions, but not enough to actually fine tune. We have separate retraining rules, which people can use in the open division. So there was a question from Ray, how does the MOE handle tokenization for each model? So I think in Michelle or Miro, correct me if I'm wrong, but there's a single tokenizer, and I wouldn't think about it. Each expert isn't really a model per se, although it could stand on its own. I would think about it as there is a single model that has multiple experts. So I think you're going to have the same tokenizer for everything. But I think it is quite, is the tokenizer here the same as, for instance, in GPTJ or in Llama 70B? Michelle, Miro, do you guys know that? Or should we take an action item and follow up?
I'm not sure.
Michelle?
Can we take an action and follow up?
Okay.
I want to double check a few things.
Yeah, that's a great question, though. Okay, Ray, you get bonus points for stumping the MLPerf team. All right, and then Sean asked, some MOE vendors talk about the number of active out of total parameters. And is that a consideration for that aspect of MOE? Someone want to chime in here? Someone from the task force? Miro, you were on the task force, right?
Yes.
Yeah.
So what is the question exactly? Someone is if whether we
Were we thinking about the number of active parameters and total parameters? I mean, I would assume we were, Sean. You know, the number of active parameters will vary on a query by query basis.
Right.
I don't know if that's something that we're tracking. I don't know. Did the task force profile that?
I don't think we did. No, it wasn't.
Yeah. I mean, it's something we could certainly collect going forward, but you know, there's a lot of secondary metrics that we are consideration for inclusion. Dina asked a question about the difference between the open and closed division. So that slide wasn't in here. Apologies. So in the closed and open division, you have to use a model that is equivalent to our reference model. So if you take, say, ResNet 50, we have a set of rules that specify the optimizations you can use. So for example, we allow you to change numerical format. We allow changing nonlinear layers and using a numerical approximation within some reason. But we don't allow things like really changing the model and cutting out a layer, right? If you cut out one of the 50 layers of ResNet 50, it's not really intellectually honest to call it ResNet 50 anymore. That would be ResNet 49. In the open division, you can change the model. And so that allows, and you can retrain. And so that allows for a much more significant set of algorithmic innovations. And there's actually a ton in this round that I want to call out. There's really a lot of very interesting work in terms of model compression that does require more than just quantization. And that's actually super interesting. It's another example of the diversity that we had in this round. So thanks for asking that great question. So in the closed division, basically, you're going to start with the reference model. You follow our rules on what you can do to that model, and then you try to get it to go as fast as possible, of course. In the open division, you don't need to follow all of those rules. And sometimes it's just a small tweak outside of the rules. And sometimes you might be using a totally different model, right? You might say, I have a system that, you know, instead of being optimized for dense representations, dense models, I want to do only sparse stuff, right? And so you significantly change around the model to suit what you're doing or to highlight a point, right? And so Francis asked the question, how do we confirm that the rules are being followed in the closed division? That's why we have the peer review process. So many of these submissions were done weeks ago. And there is an extensive peer review process where everyone looks at everyone else's submission, you know, much like in an academic setting. Again, this is one of the ways we draw on our academic heritage to make sure that everyone is following the rules carefully.
And we also
and that is, you know, but part of the ethos here, which is, you know, again, we want to celebrate innovation and novel techniques, but we want to make sure that it is, you know, a level playing field, and folks aren't doing weird things. So, and we can send out this deck with a little bit more detail about the closed and open division and the available categories.
Right.
All right.
There's only one more slide, which we don't need to spend a lot of time on.
Yeah, this is just the examples here.
Right.